Hello students, today we are going to take some more examples for sum of an infinite GP. In that we will learn applications of infinite GP. Okay. So first example is a square is drawn by joining the midpoints of the sides of a square. A third square is drawn inside the second square in the same way, and the process is continue indefinitely. If the side of the square is 10 centimeter, find the sum of the areas of all the squares so formed. Okay, means here first square, suppose this is first square having name is A1, A2, A3, A4. So this is first square. Then second square. This is first square having side is 10 centimeter. Okay. Second square we have to draw by joining the midpoints of the first square. So if we join this midpoint, so this is second square. So we are giving name here B1, B2, B3, B4. Okay. So after that third square we have to join the midpoints of this second square. Okay. We have to give here name C1, C2, C3, C4 and so on. So we have to draw square by joining the midpoints of previous square, and this process is continuing indefinitely, and we have to find the sum of the areas of all the squares so formed. Okay. So first square, that is A1, A2, A3, A4, that is the first square having side is 10 centimeter. Okay. So let A1, A2, A3, A4 be a square of side 10 centimeter. Okay. Now how we find side of second square? So if we have to find, suppose this B1, B2. So B1, B2 how we find? So this B1, A2 and B2, this form a right angle triangle. So by using Pythagoras theorem we can find side of this second square. Okay. So B1, B2 is equal to square root of B1, A2 bracket square plus A2, B2 square. Okay. Now B1, A2. So B1 is the midpoint of A1, A2. So B1, A2 is a 5 centimeter, because A1, A2 is 10 centimeter. This is midpoint. So this distance is 5. This is also 5. So 5 square plus 5 square. Okay. So 5 square plus 5 square, that is a 25 plus 25, 50, or we can write 2 times 5 square. Okay. So it is a 5 root 2 centimeter. Okay. So second square having side 5 root 2 centimeter. So here we can write B1, B2, B3, B4 is a square of side 5 root 2 centimeter. Similarly, third square, how we find this side of the third square? This third square is joining by midpoints of second square. Okay. So if you have to find, suppose C1, C2, then C1, C2 we can find by using Pythagoras theorem. That is the square root of B1, C1 square plus B1, C2 square. Okay. Now B1, C1, that is a 5 root 2 by 2. Okay, because this is B1, B2 or B1, B4. This side is 5 root 2, but we have to take B1, C1. So that is a half of B1, B4. So this is a 5 root 2 by 2 square plus 5 root 2 by 2 square. Okay, so it is a 2 times 5 root 2 by 2 square. Okay, so if we take outside the square root, so it is 5 root 2 by 2 into root 2. So it is 5, this is root 2 into root 2 upon 2. So it is a 5 centimeter. Okay, so third square C1, C2, C3, C4 is a square of side 5 centimeter. Okay, so we will get sides, that is a 10 centimeter, that is a side of first square, then 5 root 2 centimeter, that is the side of second square, then 5 centimeter, so this is the side of third square, and so on. Okay, so if we have to take area, okay, so get rid of this. So area, that is the capital A I am using for sum of the areas of all squares. So first square having side 10, so that is a 10 square, plus second square having side 5 root 2 square. Okay, that is the area of second square is 5 root 2 square. Third square 5 square, plus and so. This is the GP 10 5 root 2 5. Okay, so here, and this geometric series we have to take up to infinity. So formula is A upon 1 minus R. So A is 10 square upon 1 minus R. Now R is, or if we simplify this, 10 square is 100, 5 root 2 square is 5 square is 25, root 2 square is 2. So 25 into 2, 50, plus 5 square is 25, plus and so on up to infinity. So area of the sum of the all squares is 100 divided by, now this is 50 divided by 100, that is a 1 by 2. So R is 1 by 2. So 1 minus 1 by 2. So A divided by 1 minus R. So 100 divided by 1 by 2. This becomes reciprocal. So 100 into 2 upon 1, that is 100 into 2. So what is the remain? 200 square centimeter or centimeter square. So this is the area of all the squares. Okay, understand this. Now we will take second example. Second example is, after striking a floor, a certain ball rebounds 4/5 of the height from which it has fallen. Find the total distance that it travels before coming to rest if it is gently dropped from a height of 120 meters. Okay, means initially this ball dropped from a height 120 meters. Okay, it rebounds and goes up to 4/5 of 120. Okay, and again fall down. Similarly, at the second time when it rebound, then again it goes 4/5 of this height and falls down, and until it comes rest. Okay, so we have to find this total distance. Okay, so initially ball dropped at or from a height 120 meters. Okay, so this is initially this ball dropped from a height 120 meters. It strike on the floor and again it rebound up to height 4/5 of this height, means 4/5 of original height. So 4/5 of 120. So second time or first time when it rebound, first time. Okay, so this distance is when it rebound first time, so it goes up to height 4/5 of 120 and again fall down from this point. So second time how much distance cover? Sorry, first time when it rebound, so that is a 2 times 4/5 of 120. Okay, because it goes up, that distance is 4/5 of 120 and again fall down. So that is distance. That distance again 4/5 of 120. So it is a 2 times. Okay. So this is first distance is 120. Again it rebound. That is the 2 times 4/5 of 120. Means this is 4/5 of 120, and again this is 4/5 of 120. Okay. Actually it is in same, means here it is 4/5 of 120, in same line it is, but for diagram I am taking like this way. Okay, but it is in the same line. Okay. Now for the first time, when it rebound for the first time, ball cover distance, that is a 2 times 4/5 of 120. Then when it rebound second time, so it cover distance 4/5 of this distance, 4/5 of 120. Okay, so it is equal to, and this distance is 2 times. Okay, when it going up and down, so 2 times this distance, so it is equal to 2 times 4/5 of, means 4/5 square into 120. Okay, and it goes up to infinity. So first initially that distance is 120, then when it rebound first time it covers distance this, second time it covers distance this. So if we if we take GP from this distance, okay, if we take sequence from this distance, then this distance is common GP. Okay, if we take 2 common, and if we observe this numbers 4/5 of 120, then 4/5 square into 120, then these numbers form a GP. Okay, so we can find total distance, that is total distance is equal to this 120 as it is, plus, now from all these distances, okay, this is first distance, this is second distance, and second time. Okay, so from all the distances we can take 2 common. So 2 in bracket, first is 4/5 of 120 plus 4/5 square into 120 plus, and so on up to infinity. Okay, so 120 plus 2 into, now this is GP, with first term is this 4/5 of 120, and second term is, if we divide this term by this term, 120 will get cancelled, 4/5 square upon 4/5, so one time only 4/5 remain, so a divided by 1 minus r, that is 1 upon 4/5. Okay, now 120 plus 2 into, now if we reduce this, 5 2s are 10, 24. Okay, 24 4s are 96 upon 1 minus 4/5, that is a 1/5. So 120 plus 2 into 96 into 5. So 120 plus 2 5s are 10, and into 96, that is a 960. And if we add this 0, 8, 10. Okay, so total distance ball cover before coming to rest, that is equal to 1080 meter. Okay, understand this. Now we will take third example. The third example is, the inventor of the chessboard suggested a reward of 1 gram of wheat for the first square, 2 grams for the second, 4 grams for the third, and so on, doubling the number of the grams for subsequent squares. How many grams would have to be given to inventor? Okay, so we know that in chessboard there are 64 squares. Okay, so we can find like this way number of grams. For first square it is a 1, for second square it is a 2, for third square it is a 4, and so on. Okay, up to infinity, no, there are 64 squares, so up to 64 terms. Okay, now we can write this as like this, where 1 plus 2 plus 2 square plus 2 raised to 3 plus and so on up to 64 terms. Okay, because there are 64 squares. So here we have to use formula for sum of n terms of an AP, because there are 64 terms. So here formula is A into, we know that Sn is equal to A into r raised to n minus 1 upon r minus 1. Okay, so here A is 1, r raised to n, so r is 2 raised to n, n is 64 minus 1 upon 2 minus 1. So 2 minus 1 is 1. Okay, so what does remain? Only 2 raised to 64 minus 1. Okay, so number of cranes given to the inventor, that is equal to 2 raised to 64 minus 1. Okay, here we have to use formula Sn is equal to A into r raised to n minus 1 upon r minus 1, because number of squares are 64. Okay, so that is a finite GP, and for finite GP we have formula Sn is equal to A into r raised to n minus 1 upon r minus 1. So use this formula here. Here r is equal to 2, A is equal to 1. So total number of cranes given to the inventor, that is equal to 2 raised to 64 minus 1. Okay, now we will take next example. Fourth example is the sum of an infinite geometric series is 15 and the sum of the squares of these terms is 45. Find the series. Okay, so let geometric series with first term A, and common ratio R. Okay, so sum is given 15, that is A upon 1 minus R is equal to 15. Okay, sum of infinite geometric series, that is a GP is infinite, so formula is A upon 1 minus R is equal to 15. Okay, so this is equation 1. Second equation is given sum of the squares of these terms. So sum of the squares means A square plus A square R square plus A square R raised to 4 plus and so on. Okay, because here first term is A, then AR, then AR square and so on up to infinity. This sum is given 45. Okay, so here we have to use formula A upon 1 minus R, that is the first term is A square upon 1 minus R is here R square, so 1 minus R square is equal to 45. This is equation 2. Okay, now we have to do square of this equation 1 and divide by equation 2. Okay, so divide equation square of equation 1 by 2. Okay, so if we make square of this is A square upon 1 minus R bracket square divided by A square upon 1 minus R square is equal to 15 square by 45. Okay, so A square upon 1 minus R bracket square into 1 minus R square upon A square, this will get cancelled. 15 square is 15 into 15 upon 45. So 15 3s are 45 and 3 5s are, so remaining it is a 5. Now 1 minus R square, that is 1 minus R, 1 plus R upon 1 minus R into 1 minus R, because 1 minus R bracket square, that is 1 minus R into 1 minus R. 1 bracket will get cancelled. This is equal to 5. So if we simplify this, 1 plus R is equal to 5 minus 5R. So if we shift minus 5R here, 6R and 5 minus 1, that is a 4. So R is equal to 4 by 6, that is a 2 by 3. Okay, now r is equal to 2 by 3. If we put value of r 2 by 3 in first equation, so from 1, a upon 1 minus 2 by 3 is equal to 15. So a upon 1 minus 2 by 3, that is a 1 by 3 is equal to 15. If we multiply this 1 by 3 here, so a is equal to 15 into 1 by 3, that is a 5. So a is equal to 5. So geometric series will be, or geometric series is, first term is 5, so 5 plus second term, that is a 5 into r, that is 5 into 2 by 3, 10 by 3. 10 by 3 into 2 by 3, that is a 20 by 9, plus and so. Okay, so this is a geometric series. Understand this. Now we will take last example. The fifth example is, if each term of an infinite GP is twice the sum of the terms following it, then find the common ratio of the GP. Okay, so I am considering GP. Let GP with first term a and common ratio r. Okay, then first term is a and common ratio r. Okay, now what is given? Each term of an infinite GP is twice the sum of the terms following it. Means if we consider nth term, so nth term is equal to 2 times twice the sum of the terms following it. So 2 times an plus 1 plus an plus 2 plus an plus 3 plus and so on up to infinity. Okay, means each term of this geometric progression is 2 times the sum of the terms following it. So after n, which terms are there? N plus 1, n plus 2, n plus 3. Okay, so each term is 2 times the sum of these terms. Okay, now so I am considering general term, that is nth term. So n is equal to 2 into sum of the terms following it. Means after n, which terms are there? N plus 1 term, n plus 2 term. Okay, so nth term is equal to 2 times sum of these terms. Okay, so nth term we can write a into r raised to n minus 1. Okay, is equal to 2 into this n plus 1 term, a into r raised to n plus 1 minus 1. Okay, we have formula, nth term is a into r raised to n minus 1, but here n plus 1 is there, so n plus 1 minus 1. A into r raised to n plus 2 minus 1 plus and so on up to infinity. So that is a 2 into a r raised to n, a r raised to n minus 1, sorry n plus 1 plus and so on up to infinity. Okay, so this is geometric series up to infinity. So 2 into first term is a into r raised to n, that is a upon 1 minus r. We are using this formula, a upon 1 minus r. So here first term is a into r raised to n upon 1 minus r, common ratio is r, and here a into r raised to n minus 1 as it is. Now we have to simplify this. So a into r raised to n minus 1 is equal to 2 into a into r raised to n upon 1 minus r. So this a will get cancelled. R raised to n minus 1 we can write r raised to n into r raised to minus 1 is equal to 2 into r raised to n upon 1 minus r. This r raised to n will get cancelled. R raised to minus 1 we can write 1 by r is equal to 2 upon 1 minus r. Cross multiply this, so 1 minus r is equal to 2r. So 1 is equal to 3r. So r is equal to 1 by 3. So common ratio of this geometric progression is 1 by 3. Okay, understand this. For more practice, solve example from given worksheet, and in next video we will start next point, that is the properties of GP.